looking for? Look at all the things that are happening. Do you see how, like, it's getting C added to it, and then it's getting multiplied by H, and then it's getting multiplied by 1/2? What's the last thing that's, like, happening to it? Like, what's the furthest away from it? I kind of use PEMDAS when I say, like, furthest away. I mean, like what interacts with the B, like, last? Dog, I don't really know. It's okay, dude. I think the 1/2 is. I think this is the thing that's the furthest away. Okay, right? Here's how algebra works. You're just trying to strip everything off of this somehow. Okay, and in order to do that, you just need to do the opposite of what's happening to it. So I'm gonna show you here, Wolf. Okay, 1/2, right, is being multiplied by all of this stuff, right? I'm trying to get to this eventually. What is the opposite of multiplying something? Opposite of multiplying. Do you see how 1/2 here is multiplying by this whole stuff? Dividing. Good. Okay. That's what I'm going to do. I'm going to divide both sides by 1/2. Okay. Nice. Okay, great. So, if I divide both sides by 1/2, right? This is going to go away. And I'm going to have A divided by 1/2. Do you know how to do A divided by 1/2? This is an important skill to have. Do you know how to divide things by fractions? Okay. What you do is they call it like keep, change, flip. Is what I hear this. I hear keep, change, flip. All right. And what that means is I'm going to keep this. I'm going to change this to a multiplying. And then I'm going to flip this to 2/1. What does this become? A times 2/1. I know y'all are used to numbers. Yeah, A2. Good. A2. The better way to write this, Wolf, is write this as 2A. Always put the number in front of the letter if you can. It just makes things nicer. Okay? So, yeah. So, this whole thing now is 2A. This is gone, right? And now we're left with is equal to HB plus C. Okay? Your teacher earlier, this is another trick they did, okay? Which was they saw, okay, in order to get rid of the 1/2, I don't have to divide by 1/2. I could also just multiply everything by 2. Because 2 times 1/2 becomes 1. And then I just get the same thing. 2A is equal to this. That's what they're doing. But I don't want to confuse you too much, okay? All right. All right. All right, we're still trying to get to the B here, right? What's like outside the house trying to attack the B? What's happening? The H. What is the H trying to do? It's trying to times. Okay, what's the opposite of times? Divide. Right. So again, I'm just going to divide both sides by H. All right? So this is going to go away. And then we're left with 2A over H is equal to B plus C. Okay? Yo, what's up, Destiny? How's life? Doctor. How's life, dog?
That's a new one.
Doctor. Doctor. Yeah, it's Chewy. Chewy doesn't come out very often. I'm helping a kid with how to do algebra. That's what we're doing.
Very cool. Don't let me interrupt.
Oh, good. Oh, good.
I just watched Interstellar.
Oh, that's a great film. Yeah, the Tesseract, dude.
Oh my god.
Tesseract.
Yes, it is.
Yes.
I don't even know what the Tesseract is.
I don't. I need to get someone to talk about Tesseracts on the stream. I think that'd be pretty cool.
Is that why the one Infinity Stone is called the Tesseract? Is that actually like a thing? I thought.
I think it is. I think it is a thing.
Up until about an hour ago, I thought that was a term that the Avengers made up.
No, it's real. I think a Tesseract is a real thing. Maybe one of the math guys can tell you what the Tesseracts are. Yeah. Is that a math term, guys?
That'd be pretty cool.
Math streamers. Is that a thing? Is a Tesseract a math thing? I think it's a math thing. Okay, nice. All right, here. All right, so do you get this? so far, Wolf? Do you get how I divided by h? This went away. Now I have 2a over h, right? Okay. Still, again, we're trying to get to the b. All right. What's the next thing happening? So when you have something here with parentheses and nothing else is outside of it, you can just get rid of these parentheses. Let's just get rid of these. It just makes things prettier, right? Okay, let's do that. Away they go. They don't really do anything. If the parentheses don't do anything, you can get rid of them. What's the last thing happening to this b? Adding. Okay, what's the opposite adding? Subtract. Good. Subtract c. Subtract c. Okay. So watch what this is going to become. This is going to become 2a divided by h minus c is equal to b. Do you see that? Good. Okay. So let's go to what your actual question was. And look, you can see this is kind of the same thing. Well, your teacher wrote it kind of weird. Oh wait, did they solve for b? Yeah, they solved for b. Oh, yeah, they said 2a over h minus h over c. Oh, okay. This is the last thing they did, which I don't agree that you have to do, Wolf. But if you wanted to combine these things into one fraction, do you know how to do that? Okay. Things combined into fractions have to have the same denominator, okay? Oh, you can, one sec. I'll give you permission. You can swear. There you go. You can go say whatever. I don't care now. Okay, whatever. My teacher is an ass, so I have to do it. Okay, all right. Okay. So, here we go. They need the same denominator, right? So right now, the c as it is, this is the same thing as saying c divided by 1. How do I make it so that these things have the same denominator? Wrinkle in time. Well, that's cool. You don't know? Okay. Let's say, for instance, I have 1/3 minus 1/4. Do you know how to subtract? Or let's make it even easier, sorry. Let's say I have 1/2 minus 1/4. Do you know how to subtract this? You know what a half minus a quarter is? Okay, he doesn't know. It's all right. Okay. What you want to do is you want these things to have the same denominator. So I'm going to see how can I make this thing look like this, all right? The way to do that is to multiply the top and the bottom both by 2. Okay? Because watch what... And this is the rule. Whatever you multiply the bottom by, you have to multiply the top by as well. So this would become 2 over 2 times 2, which is 4, minus 1 over 4. Now this should make more sense, right? 2/4 minus 1/4 is how many fourths? One-fourth. Yes, good job. Okay. Do you see the strategy here, right? Do you see how I had to turn this thing into the same thing as this? And I did it by multiplying the top and bottom by something to get that? Yeah, kinda. Okay. Well, it's kind of the same thing here, right? This has an H. This has a 1. Okay? So I want this to have an H on it. Right? So, you know, I could multiply the bottom by H, but if I multiply the bottom by H, what do I also have to multiply the top by? H. Very good. You see how now this is 2a over H minus CH over H? Can I combine these now because they have the same denominator? Yes. This becomes 2a minus CH all over H is equal to B. Does that make sense? Do you see how these two things just like came together? Yes, cool. That's why your teacher's answer is this. 2a minus HC over H. I mean, whatever. She flips the order of it. Cool, whatever. Okay, cool. All right, does that make more sense to you, Wolfslayer? Yeah. Yes. Okay, good. Let me do some more questions. If I have time, I'll come back and do your other one. Yeah, I hope that helps out, dude. Nice. Yeah, and so that's a great example of when you asked your friend like what the question was. Yeah, that's very good. That's what I'm at. That's what I'm talking about. Like when your teacher should give you like, oh, what the fuck, Microsoft? What? Go away. Your teacher should give you like something, you know, written out like this. Like here, this is what I wanted to know. We're supposed to find. Okay. Cool. All right. FCW, what was your question, dog? You want to come on stage? You can come talk if you want. Thanks for waiting, dude. I know we've been streaming for an hour and a half so far. Maybe we'll hit 3 today.
Hey, man.
What's up, dog?
Just, for,
This stuff right here. Ooh, oops, oopsies. Topsy-turvy. Ugh. Ew, dude, what? ln inverse? Or no, it's ln to the -1. Okay. Okay. Sure, Monkey. Yeah.
I just learned it today. I have to use like Euler's number.
Yeah, that's just an e. That's just an e. Just e to the sum. Well, ooh, that's way too big. Yeah. So what we learn here, right, is that ln is the same thing as like log base e. Like ln of x is log base e of x. Is all they're saying. Okay.
Oh, sorry. My dad was talking to me. Can you repeat that?
You're okay. So ln of x is the same thing as the log base e of x. Have you seen this before?
Yeah.
Where e is Euler's number. I think math people will get mad. They're gonna call it like Euler's. They say it's like Euler's number. I know. I'll cut Euler. Whatever.
Euler or something.
I think Euler's fine.
Use it interchangeably.
I think I like Euler, honestly. Okay. All right. Okay. So this is actually kind of similar to the last question I was working on with the other kid. If you're trying to solve for something, start doing shit outside of it first, right? So we'll get to the ln stuff eventually, right? And I assume that this -1 is on this and not on the whole ln. If it was on the whole ln, I think it would be out here.
Yeah, I'm pretty sure it's like just on x-1.
Good. Okay. All right. So what's the first thing happening to this? What's the outermost thing happening to this x that we're trying to get to?
It's multiplied by -2, right?
Good. So yeah, let's get rid of that. What do we do?
Divide on both sides.
Nice.
Divide by -2. Divide by -2. Right. Cool. All right. Now this is ln. I'm gonna rewrite this. I just don't like this. 1 over. Oh, actually, you know, I kind of do. I take this back because okay, I see where this is gonna come into play. Okay. And then this is going to be -3. And then what happens to this? There's something special with this.
It's flipped because it's
Good.
divided by negative.
Flips.
Nice.
Flips because divided by negative. Okay, awesome. Okay, great. Okay. What I'm going to do first here is I'm going to use what's called a log rule, which says that if I have the ln of a to the b, this is the same thing as b ln of a. Have you seen this rule before?
I don't think I have.
Okay.
Actually, like that.
Yes, b ln of a. Well, here, let me. I'll just tell you all the log rules. There's some really cool ones. So yeah, ln, or I'm just gonna say log for now. And ln just means log base e, and then we'll get into what the things are. So log of a to the b is equal to b log a.
Okay.
Log of a times b is equal to the log of a plus the log of b. Log of a over b is equal to the log of a minus the log of b. You can actually prove this one based on these two. It's actually pretty cool. If you want to see it real quick, I'll show you. So let's say I have the log of a divided by b. What's another way to write dividing by something but like multiplying? So instead of dividing by b, what am I multiplying by? 1 over b.
1 over b. Oh, okay.
Does that make sense? I know I worded it kind of weird, right? Dividing by b is the same thing as multiplying by 1 over b, right? Okay. Which, okay, do you see how this is now our cool rule here, right? When two things are multiplying, I can split them into two separate logs.
Yeah, so they're adding together.
Right? So this is log of a plus the log of 1 over b. How do I write 1 over b as an exponent?
It's squared to, exponent to b.
b to the negative 1.
B to negative 1.
So here, yeah.
Okay,
So
yeah.
anytime you got a fraction, right? FCX, you FCW, sorry. You call this b to the minus 1, right?
Yeah, yeah.
Okay. It's okay, like, and also, like, stop me if you're like, wait, fuck, I never learned that. Like, yeah, let me know, because, like, we always want to find, like, where the gaps are, like, where it's, like, the little foundational things that you need to know in order to do math. Yeah. Okay, so this is the same as b to the minus 1, okay? What rule over here does this do some things with?
First one log a to
Good.
b equal to b log a.
So what does this become?
It becomes a negative 1 log b.
Log b, right? So plus negative 1 log b is the same thing as just minus log b, right?
Yeah.
Do you see how this is the same rule as this?
Oh yeah.
Yeah, isn't that pretty
I
cool?
can see it.
Yeah.
Mhm.
It's like, oh, yay. Math is real. My life is not a lie. Okay. Good. Okay, so then let's go back to our question here, right? You see how we have something to the minus 1. What can I do with that?
You can turn it to negative 1 log x minus 1.
Good. So I can pull this, right? Just pull it out. And then you see how this is going to cancel this?
Yeah. So it
Cool.
turns-
So this goes away, and then I think we gotta switch it again though, right?
Yeah.
So now we gotta switch it the other way. Okay, cool. All right. So now I'm left with ln of x minus 1 is less than or equal to 3, right?
Yep.
Okay. The way to get rid of ln is to do e to the.
Question.
What's up?
Do the brackets mean like a absolute value of x minus 1?
No,
No, okay.
no. The parentheses, you mean?
But it's like in like the original equation it was like
Oh, these?
brackets, natural log x minus 1.
No, they just don't want to put another. They just don't want to put another set of parentheses. It just looks ugly.
Okay.
Yeah, they're using a bracket. You're right. If they're the straight bars, then yes, that's the absolute value. And then this question gets a lot harder. Yeah, because I hate doing absolute values with inequalities. It's a pain in the ass. Okay. The way to get rid of ln is to do e to the. Okay.
Oh yeah, exponentiate.
Yes.
Okay.
So you get x minus 1 is less than or equal to e to the 3, right?
Yeah.
Okay. So then move her over, right? And I get x is less than or equal to e to the 3 plus 1.
And then you just plug that in the calculator to get the answer, right?
Yeah, and like let's check. Yeah, I think that makes sense. Yeah. Well, sorry. It's not x equals 2, right? It's just x is less than or equal to e to the 3 plus 1. Yeah, it's just this.
Okay.
You should always check, right? With the equals sign, you should check to see like if that makes sense, right?
Yeah.
So if we do that, right? Negative 2 ln, and then, right, it was 1 over, and then this is going to be e to the, what did we say, 3 plus 1? And they'll just say it's equal to 6. Let's just check it, right? So, whatever, right? That goes over, becomes negative 3, and then another minus comes out, makes it 3. So then I have ln of e to the 3 plus 1 is equal to 3, right? Oh, wait. It was e to the 3 plus 1 minus 1. My bad. Because this was x minus 1, but this is e to the 3 plus 1 for x. Does that make sense, FCW? Sorry. I made a oopsies.
Could you repeat that?
Yes, yeah, sorry. Let me just read it. No, I hate when I fuck up, dude. I'm like, no.
That's all good.
No, it's just like it's bad. It's like I just want to erase myself, dude. Okay. All right. -2 ln, and then this is instead of x, I'm gonna write e to the 3 plus 1 because that's what x was, minus 1, right? All the -1 less than or equal to 6, or we're gonna say it's just equal to 6. We're just gonna check the boundary, just make sure it works. So this goes away, right? And this becomes -3. And then we're left with ln of 1 plus 1 is plus 1 minus 1 is just 0. So this is going to be e to the 3 to the -1, which is the same thing as e to the -3, right? Is equal to -3. I just had this exponent like hit this one as well.
And then doesn't the natural logs and Euler's number like cancel each other out?
Yes, but you want to pull this thing out first. You want to pull the -3 out first. That's the rule. Yeah, this, right, just becomes 1. And then, yeah, good. You get -3 is equal to -3.
Okay, so like that's means everything is correct.
Yeah, it means we're good. Yeah.
Okay.
Yes, cool. Thanks, Jeff.
Plus 1. Okay, thank you.
You're welcome, dude. Nice. Where's my clapping animation? Here we go. Nice. Here, I'll take a screenshot and send it to you so you can have it, FC. It's a good question. Or FCQ, whatever. FCW. Lots of questions today. For sure. Okay, cool. Great, great, great. All right, let's see. Yes. Taco, let's do yours. You are next. You know what I'm going to do, actually? I'm going to have you balance something that's harder, Taco. Taco, are you here? Yeah, thanks, Jeff, for being you're my guardian angel, dude. For all my math mistakes I'm making today. I got an interview tomorrow morning with Khan Academy, actually, for maybe a physics content associate role. So I need my brain to be, like, working tomorrow. The weekend just, like, throws me for a loop. You're nitpicker, Khan Academy, yeah, we'll see. Trying to get them to give us some more money. Or just a money, you know. Okay, yeah, Monkey, let's do here. I want to do like a hard one that I've done. Let me see. I did this on my TikTok at one point. Let me just grab it. Where was it? It was a chemistry question. Oh, shake frag. Here we go. This is what I want. Here's some tips for balancing chemical equations. Okay, cool. All right. Let me grab this. All right. C8 H18 plus O2 goes to CO2 plus H2O. All right, this is a good one to try and balance. I like this one. This is a good one. Okay. This is the combustion of gasoline, which is actually cool. So this is the equation for how like we burn shit. Yeah. Oh, yeah. Good to see you, not your friend. Have fun at school, man. Okay, Monkey. How do we do this? How do we do it? Where'd he go? Monkey, where you at, dude? Oh, there you go. He's got it. Okay. Just put variables in front of each term and solve simultaneous equations. Yeah. That would get tricky, dude. What? That'd be so many variables. Okay, all right. Yes, let's try to balance this monkey, dude. How do I balance this? What's up, Obama? What's up, my guy, dude? Oh, you sent me what you've been doing. Oh, yeah, let me look at what you've been doing. Oh, trig identities. Yeah, okay, cool. Yeah, I'm going to give you a harder one, Obama, after this. We got to do the chart. Yes, we do got to do the chart. All right, let's do C, H, O. C, H, O. Okay. How many carbons do I have right now on this side? Eight. Yes. How many hydrogens? 18. Good. What about oxygens? 2. Good. All right, so over here, right, we got 1. We got 2. How many oxygens do we have? O is 3. Very good. Okay.
Nice.
What do we want to try to balance first? What do we want to try to balance first? I always like to try to balance the most complicated thing, right? Also, like, kind of general rule of thumb is, like, anytime you have something by itself, balance that last. So let's try to maybe balance the carbons, okay? I have 8 carbons over here. What do I need to do over here to get 8 carbons? He says, put an 8 in front of it. Yeah, very good. Okay, cool. Nice. Okay, I'm going to put an 8 in front of there. So let's see what that changes. If I put an 8 in front of here, okay? Now I have 8 here. But, ooh, something's going to change, right? Number of oxygens. Right? Now, how many oxygens do I have now? Oxygen is 17. Good, right? You got 8 times 2, 16, plus 1 over here. So now I got 17. Okay, so now we got 17. Okay. Remember that the oxygen is by itself over here, so let's balance that last. I'm not even going to try to balance this yet. Let's balance the other thing. Let's balance the hydrogens. Okay, how do I balance the hydrogens? Hydrogen, he says, Put a 9 in front. I agree. Let's do it. Let's put a 9 in front of here. So now we have 18 hydrogens. Cool. This is good.
Nice.
These are good. These are good. Okay, but what's happening to oxygen, dude? Oxygen's getting out of control, right? How much oxygen do we now have? $25. Very good. We have 25 oxygens. Okay, good. All right. So, what I want to do is I want to balance this, right? And luckily, okay, we saved the best for last, right? We saved the oxygen for last. Now, anytime I start putting numbers in front of this, it's only going to change the oxygen, which is good. It's tricky, right? Yeah, because, like, what would I want to put in front of the oxygen here? $12.5. Exactly. Okay. Another way to write 12.5 is to say 25 divided by 2. Okay. And this is kind of a trick I show. whenever you need like a certain number of things, put the amount you want, and then on the denominator, put whatever the subscript is here. Because these things will cancel. And then you'll just get the 25 that you want. That's the trick. Yeah. I know it's technically 12.5, but this will get tricky sometimes when, like, let's say, for instance, this was like 03. Then you need this to be 25 over 3. Okay, in order for these to cancel. Does that make sense? Okay, so we're going to say 25 over 2. Okay. So, technically, this is balanced. The only issue is that in chemistry, we're not allowed to have fractions. No. Okay? So, what can I do to get rid of this fraction? It's kind of cool. It kind of works the same way as if we had, let's say we had x plus, like, 3/2 y is equal to, like, I don't know, 6. And I wanted to get rid of the fraction here. Or let's say like 6 plus z. How'd I get rid of the 2 on the bottom there? Decimal? No. Look what happens. What if I multiply everything here by 2? See how this becomes 2x, and then the 2 cancels the 2 here. So we get plus 3y. And then this would be 12 plus 2z. Like, one way to get rid of denominators is to multiply it on the numerator, okay? But in algebra, right, if I multiply something by a number, I have to do it on both sides. So I'm going to multiply everything by 2. Okay? So this now gives me, right, 2C8H18, 20 plus 25O2 goes to 16CO2 plus 18H2O, and you're done. Yeah, it's a pretty cool trick.
Well done! Well done!
Yeah, nice. Yeah, so this is important. You'll get to this when you start doing chemistry. But yeah, it's a good skill to know. Okay, cool. Obama, you're in the chat, so I'll help you out right now. What's up? Yeah, good job, monkey. Let me add him. Oh boy.
Yo.
There he is. What's up, dude? What's up? All right, trig identities? Is what you're doing? Doing some crazy trig identities?
Yeah. You said you're gonna teach me like the next step or something.
Yeah, I'm gonna teach you the next step. Sensation Black, new name soon. Sorry, Sensation, what's your new name soon, dude? What? One sec. Let me find you a question, Obama, real quick. Because let me think. After you do trig identities, have you done inverse trig stuff yet?
No, I don't think so.
Okay, cool. Yeah, let me teach you that. Okay. I mean, you know what, like, sine and cosine of, like, a right triangle is, right? Or do you?
Nah.
No?
I forgot.
Okay. I love that they now make it so they have the angles on this. This is super cool. So glad they did this. Okay, cool. This is a right angle, or right triangle, right?
Mm-hmm.
Okay. Which can have various sides to it, right? So,
Yeah.
let's say we had a triangle that had a side of, let's say a side 1 here, a side 2 here, and a side square root of 3. Or actually, let's say I don't know what the side is. Let's say I just don't know what it is. Okay. But I do know that the angle here is 30 degrees. Actually, here, let's make it a little bit more fun. Let's just say it's 4 and 8. Okay. you can use these things, sine, cosine, tangent, whatever, to figure out what the missing side is. Okay?
Yeah.
All right. What you learn is that, right, sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Okay? These are probably words you're like, what the fuck are these things, dude? Right?
That's SOHCAHTOA, right?
SOHCAHTOA.
Perfect.
Okay, so you've heard of SOHCAHTOA at least, yeah? But you've never used it?
No. I swear I've done this, but this was like last year, and I forgot everything about this last year.
Okay, good. Then we're going to do a good review because like you're going to need this for when we do more stuff. Okay. Okay. If this is my 30-degree angle here, right? Which side here is the hypotenuse?
The one that's how do I say it? The 8.
The 8. Yeah, good. The 8. Yeah, you can just say the number. Okay, that's the hypotenuse. Which one's the opposite?
4.
Good. Which one's the adjacent?
The question mark.
We don't know. Yes, good. Okay, cool. All right. So, if I'm trying to figure out this adjacent, right, this missing side, I can use these trig functions to figure out what it is. Okay? Here, I forgot to put an angle in there. Okay. Which one do you want to use?
Is it sine?
Yeah. Well, no, not sine. Because what are we missing?
Why?
What are we missing? Because we're missing the adjacent.
Adjacent, right?
See how adjacent isn't in here at all?
Yeah.
Yeah, you want to use one of the trig functions that has the thing you're looking for.
Then cosine.
All right, let's use cosine. Okay, so I'm going to say the cosine of what? What angle are we looking at?
8. The
No,
hypotenuse.
30 degrees.
Oh.
Cosine of theta. Theta is the angle. This is theta. Okay. The cosine of this angle is equal to a ratio of the sides. Which ratio of the sides is it?
The fraction?
It's a fraction, yeah. But what
So
sides?
is the question mark over 8?
Good. Let's just call that x over 8. Okay? Do you see now that you could solve for what x is?
Yeah.
How can I do it?
Never mind. I don't know. Wait, what? Don't you just plug it into a calculator? That's what I do.
Yeah. But you need to do something first. I would do something first. You want to get this thing by itself. It's been the theme the whole theme of this. Yeah, multiply by what?
X?
No. No.
What?
God!
Bro, what? Wait, what am I trying to get rid of? X or 8?
We're trying to get rid of 8. I want x. I want to get x.
8. Multiply by 8.
Multiply by 8. Yes, there you go, dude. Okay, multiply by 8. Cool. The other way, like, if you want to do this, dude, bro, think about, like, the butterfly method, right? Is it, like, this shit or something, right? It's like, I'm a butterfly. You ever seen that?
Okay.
I don't know. Okay, whatever. Yeah, so you just multiply by 8, Obama, right? Cool. All right. So then I get that x is equal to 8 cosine of 30 degrees, right?
Perfect.
Yeah.
And that's something you can put in your calculator. It turns out that the cosine of 30 degrees is the square root of 3 over 2. So this is 8 square root of 3 over 2. Which ends up becoming what?
What? Yo, I don't know. 8 square. What?
Well, can you simplify that? Okay, so here. This comes from the unit circle. Do you remember this fucking mess? Right, this thing? Like with all the...
Sadly.
Yeah, right? Yeah. Whatever, this thing? Yeah. If you look up the cosine...
Memory.
Well, I implore everyone to watch my TikTok videos on these because I've explained it so many times. Maybe I need to make a new one for people. You know?
We'll make like a cosine tangent one.
Yeah. Where did I do it? I had it here. Here. It was like, yeah. Here's like the special trig functions. Yeah, these. I teach basically like how to how to do anything with the unit circle without like
Fun.
memorizing all this. Like I mean, this shit like sucks, dude. Like, right? Tangent are at 30, 45, and 60 degrees. So a lot of times teachers will ask you to memorize some dumb unit circle. Yeah, fuck this, dude. This thing sucks, right? No one wants to memorize this thing. This thing sucks. Where you only have to memorize 2 triangles. Go watch the video. The 45, 45, 90 triangles. All you have to know are two triangles. And once you know the 2 triangles, you can do all this stuff in your head. It's so super easy.
Do you still have to do that? Do you like relearn that in pre? Because like pre-calc just feels like another algebra, just a little added on. That's all.
No,
Is it
so
just
what?
That, basically?
So what pre-calc is doing is it's getting you ready for calculus, which means in calculus you need to know that the cosine of 30 degrees is square root of 3 over 2. You have to know that. It's just like it's important. That's why they're running you through it again, because they want you to have the the basic skills to do calculus. It's like, let's say that you wanted to go watch some anime, but you don't have any headphones. Like, how the fuck are you gonna watch anime? Right? I mean, unless you like the subtitles, I guess, or something. I don't know, but meh. Yeah. So there's minimum things you need in order to be able to do stuff. Yeah. Okay.
Yeah.
Okay. Cool. All right.
Yo, I'm just setting my classes this week, so.
Oh, okay, good. Let's set him. What were you saying, Sensation, dude? What's up, my guy?
So I was just saying, I need subtitles all the time.
I need subtitles all the time. Yeah. Yeah.
You would expect my Japanese to be good considering how long I've been learning it, but no, I need subtitles.
Have you been to Japan, Sensation?
Yeah,
What's the new name, dude? What's your new name coming in? What's the new name, bro?
I haven't decided yet.
But tell us, why are you leaving Sensation Black behind? I kind of like Sensation Black.
Because it's been taken and I need something unique.
Oh, it's been taken by what? By like Twitch?
No, Sensation Black is a rave thing in Central Europe somewhere.
Dude, what? I need to look this up, dude. You said rave thing in Central Europe. You got my attention.
Or is it Northern Europe?
Sensation Black is a darker hardstyle and hardcore like techno thing in Amsterdam. Oh hell yeah, dude. I'm not the biggest fan of hardstyle, but oh wow. Wait, formerly known as Sensation Black.
Yeah, still taken.
Still taken? It's now called Sensation White. It reminds me of like Gandalf the Grey, Gandalf the White. You remember that? Okay. I digress. Okay, Obama. Yeah, you in pre-calc you're gonna learn, and please just those videos I post. That's how you do it. This is how you know this is square root of 3 over 2. So this gets you 8 times the square root of 3 over 2. Okay, and then I ask you like, how do you simplify this? You can simplify this. Do you know how to simplify? This is just multiplying fractions. Obama.
8 over 1?
Well, 8 over 2 does not turn into 8 over 1.
No. Do you put 8 over 1? Like.
Oh, like
or
this. Yes, yeah. Okay, sure.
Yeah.
Okay, but I can still simplify this, right? See how it's 8 times something divided by 2? What is that going to give you?
Yeah.
Yeah, what does that give you?
8 times. Wait, what? Can you say it again?
8 times something divided by 2.
12?
No. Okay, so watch. I can flip the orders of these things, right? Do you know how, like, you know that A times B is equal to B times A?
Yeah.
Right? Okay. And when I multiply fractions, right? You see I do this times this over this times this?
Yeah.
I'm going to flip these. So it's 2 times 1. Does this maybe help you out a little bit?
A little, yeah.
Okay. What does this simplify to? Do you see how like this maybe like simplifies to something?
4 times square root 3?
No.
Yes. Yes. That's what I want you to see. So 8 squared, like if we have 8 times the square root of 3 over 2, intuitively, you should be able to just see that this will cancel to just become 4. This will become 1, and then it's 4 square root of 3.
Okay.
Right?
Mm-hmm.
Okay, nice. Cool. All right, that's enough learning for today. But come by and let me teach you more of this. Obama, you need help with this. Like, let me help you, please.
I truly do. Last year, I think I barely. This is the quarter I got a C on. Finished off
Then
with a C
yeah,
because of
okay,
this.
so here, little heads up, little, you know, Dr. Gold advice time. You can't just forget this shit. No. You can't just be like, oh, I didn't learn it, I don't need to use it again. Math doesn't work like that, right? I know in history class or like whatever the fuck you're like, oh, I memorized like George Washington had 19 teeth or something. Like, who cares? That's not necessary, right? In order to go to another history class about like, I don't know, China or something. Math all builds on itself. The stuff you learn in every class gets used in the next class. So if you do badly in one of your earlier classes, you're gonna get fucked when you get to the higher class. So don't do that. You know, like let's help you out. So I can tell there's some core things here, Obama, that you should know, and it's okay that you don't.
Geometry, because I absolutely did not pay attention to geometry. Not a
Well,
single thing.
and I agree. You saw me ranting at geometry earlier today. Like I have my qualms with geometry. And actually, okay, out of all the math classes, if I had to pick one that I had to like, I don't know, black out and not learn anything in, it would be geometry because I don't think it gets used as much as everything else does. But it's still important because yeah, similar triangles come up a lot. But all those fucking proving like angle shit, like, dude, fuck that, dude. That's just fucking just theorems and whatever. I used to get drunk before my numerical methods class, lol. Penn Center, you want to know a funny joke? During my, it was my plasma physics final, the teacher said we could bring in anything to the exam. Literally anything. That's how hard it was. He's like, I don't care what you bring. Like, you're still gonna get like screwed. So I brought in a bottle of Jack, brought a fucking bottle of whiskey into my exam, and I said, "This, yes, I know, yeah. Actually, I think it was Johnny Walker Double Black is what it was. Jack's a little cheap, but yeah, I was like, I'm gonna bring some liquor into this exam because that's the only way I'm getting through this." Yeah.
What happened?
I passed. You know, it was okay. I mean, once you get to grad school, man. Yeah, he said you could bring anything. So I said, I'm gonna bring a fucking drink. Like what? Like, yeah, I gave it to my classmates and stuff. It was kind of fun. Yeah.
Yeah, I don't think. Would they still allow that?
You know what? I don't know in today's culture if they would. I don't think a lot of what I did as a kid would be like allowed in today's culture. But yeah, when I went to grad school, it was okay. I'm sure nowadays maybe someone would complain and like throw it up on YouTube and they would make some like, yeah, you know, Irma Gerd, like UCLA alcoholics or something. And I'm just like, hey, chill. Like, hey, Monkey. Yeah, Monkey's here. Yeah. Yeah, we can't do that anymore. You know, we had okay, another little story time thing. My advisor in undergrad for physics used to have this tree like in a pot, and it was just filled with wine corks, like just an intense amount of wine corks. Must have been like 60, 70 of them. Like it filled up a whole fucking thing of it. And then above it was like a letter, like he had stapled on the wall. And it was a complaint from the department telling him you can't drink wine in your office. Like there's no alcohol allowed on campus. You can't drink wine in your office. And he had the thing with all the corks to show how much like he just didn't give a shit. He was just like, he's like, I'm tenured. They can't do anything to me. What? Like it's a unique thing about being a professor is that they really can't fire you. And that's how crazy it is. But you have to get tenure to become a professor it's an insane journey. But once you get to it, yeah, they really can't fire you. Especially if you have a Nobel Prize or something, then they really can't fire you. You can get away with a lot of shit. I remember another story about what was it? One of my friends was saying they had an experiment they were running in Japan or something, and it was some real sensitive like physics stuff they were trying to detect, and then they kept noticing that their experiment smelled like piss, like something was pissing on their experiment, and they were like, this is kind of weird and whatnot. So at some point and it was ruining the data and things, so they set up a camera to like watch their experiment, like a hidden camera, and eventually, they caught what was happening. And so they go to like the dean of the school and they say, hey, like there's something like really messed up here. Like someone's doing some fucked up shit.
We just need to know that, like, you're going to fire this person if we tell you what they did. And he's like, well, what do they do? And they're like, you have to promise us you're going to fire him. Like, this person is caught on camera urinating on our experiment because they hate us. Like, there's some pettiness within science sometimes. And accurate Dean voice, yeah, thanks for the baby voice. And they show it to him, and it ends up being this, like, Nobel Prize winning, like, physicist at the university. And the guy's like, that's fucked up, but I'm sorry.
I can't fire him. And I was like, what? This is a guy, like, literally, like, urinating on somebody else's experiment. Literally, like, taking the piss out of it. Yeah, and they couldn't fire him. They're just like, we can't. And you get this, man. Like, with a lot of geniuses, especially in science, come a couple, like, behavioral issues. I guess because they focus on other things. So, yeah. But he was a genius, a Nobel Prize winner, so they couldn't really fire him. So they didn't. Yeah.
I'd have fired him out of a fucking cannon.
Yeah, I know, but like for whatever, like, you know, in the university lore of like once you're tenured, and especially if you have a Nobel Prize, you're untouchable. Yeah, it's so gross.
That's not a problem here.
Oh, is it not in the UK? Maybe you can fire people. In the US, you can't. You really can't.
I've never heard of tenure in this country, like ever.
Oh, interesting. Yeah, tenure is a huge thing in the US. It's nuts.
Next of a capitalist eventuality.
Yeah, well, yeah, it is capitalist, right? Yeah, it's keep the.
Because England, well, no, not England. All of the countries in the UK have massive class problems.
Yeah. I mean, we have some big class problems too, honestly. I mean, I see it when I go out. Ponzi what? Yeah, dude, it is. What is Penn Senator says, I tell people that managing wineries of teenagers was easier than managing my department. Oh, wow. My employees were all 19 and easier to manage. Yeah, they're moldable, I guess. But yeah, once people get older, they get kind of stuck in their ways. They don't really want to, like, change. And yeah, if they were used to, like, oh, back in my day, we used to slap women and tell them to make us sandwiches, like, you know, because that's what they did, I guess, in the 50s and 60s. Like, you're telling them nowadays they can't do it, and they're super stubborn. Not that you should do those things. No.
So you slap your wife with a sandwich, right? Got it.
She has to make the sandwich for you, then you slap her. That's terrible.
With the sandwich.
All right. Who else am I doing? Whose question am I doing? Okay, we got a couple people here. I got Noise, I got Doggy, and I got Ethan. Okay, so here. Noise is asleep. So Doggy or Ethan, whoever shows up first, I'll do their question.
Just a quick one.
What's up? What's up, Sensation?
At the moment, I'm doing 3-dimensional trigonometry.
Okay, cool. What's good?
What's the point?
What's the point of what? Of 3D trig?
Well, what's the point in like finding the center of a fucking cube or something?
Oh no, that's cool. No, I got you, bro. A lot of it has to do also with like center of mass, right? You know. So if you know, if you have like a 3D shape or something that's, you know, like, I don't know, something weird or whatnot, and you want to know where's like the balance point, then you need to know where the center is, right? That's an important thing for it. I mean, trig is important for finding dimensions, for finding angles, and then a lot of things we do in life for 3D. So that's how that works. How does putting ice in a deep fryer work? Like for the reaction? I don't know. It probably just melts the shit out of it. There's actually a cool thing about that. I'll show you a video later about that. All right, Doggy, what's up? Sublimation. Yeah, because it goes from solid to gas really quickly, right? Yeah.
Yes.
I mean, have you all seen the classic where like they throw boiling water out in ice and it instantly turns into snow? That's a cool that's a physics thing right there. Okay. Doggy says, describing linear motion on graphs, objects traveling on a straight line. Okay, cool. Do you want to come up and speak, dogs? Do you got a mic or something? Or you can chat if you want, or talk. Yeah, talking's cool. Whatever you want to do. I assume you're doing like velocity graphs and position graphs, probably, right? Describing linear motion, object traveling on a straight line. Okay. Well, let's think about that. Let me find an example question for you, Doggy. Yeah, Sam, I don't think it's a reaction. Putting ice in a a deep fryer because a reaction means there needs to be a chemical change. I think the water just changes state. I'm pretty sure. Water, I don't think reacts with oil. It doesn't even mix with it. Oh, okay. That's cool. Yeah, no, that's fine. Totally cool. Let me get an example question for you, dog. Yeah, you can chat. That's totally cool. Okay. All right. I do know it. Of course, this is physics. Okay. So here's an object, okay? And this is a graph of its position as a function of time. Does that make sense there, doggy? Dog. I'm just going to call you dog, dude, because doggy sounds kind of weird. What, here, doggy. You want a fucking treat? Yes, okay. Here's a graph that shows the position of something as a function of time. Okay? So for instance, as like my clock moves forward, right? In time, like as I'm watching my clock, this graph tells me what the position of something is. So for instance, at time equals 0, it's at position 0. Right? At time equals 1, it's at position 2. At time equals 2, it's at position 4. At time at position 3, at time equals 3, it's still at 4, right? And then, so here, if we wanted to like kind of like show what this looks like on a number line, let's do that. Let's do like 0, 1, 2, 3, 4, right? And then here, let me take a ball. Okay. So at t equals 0, right? When you're at 0 seconds, it's here, right? After 1 second, it's moved here. After 2 seconds, it's moved here. And then in between 2 seconds and 3 seconds, it just chills, right? So it doesn't go anywhere. And then at 4 seconds, right? From 3 to 4, it moves back to 2. So really, it kind of does this, right? It goes like, it hangs out here, and then it does that. That's what the motion of it is, okay? A way to think about this, right, is like in terms of the velocities of it, right? So, this is a graph of x versus t. The other graph that you're usually going to have to make is going to be a graph of velocity versus time, okay? Versus time. All right, let me use a different, let me use black, sorry. This is not coming out too well. This is velocity. So dog, if your teacher asks you, for instance, to describe the motion, you would say, okay, cool. It moves at a constant speed from 0 to 4 in the first 2 seconds. It stays stationary from 2 seconds to 3 seconds, and then it moves backwards at a constant speed from 3 seconds to 4 seconds. The reason why we say constant speed, okay, we're going to get to that, is that speed, which is like velocity, but it just doesn't have direction, is related to the change in this over the change in time. So this is what we say. So velocity is equal to the change in position over the change in time, okay? Which if a graph is position versus time, do you see how this is the same thing as delta y over delta x? What is delta y over delta x in math? What is that? People messaging me like crazy. Stop. Oh, I think you remember. I feel embarrassed if I get it wrong. No, bro, don't. Okay. Another side step. Okay. Don't ever feel embarrassed about like not knowing something. That's what I'm actually trying to do with this. This is what office hours is, and I get it. Like, you don't want to raise your hand in class because you don't want to look stupid, right? But that's not real. If you don't understand what it is, like, I guarantee you no one else fucking knows what it is either. They're just all too scared to ask. And this is why this is online. It's anonymous. Your name is obviously not actually Doggy, so don't feel embarrassed. You can ask whatever you want, you know? it's more important that you learn than you like keep your ego up of like, oh, I'm smart. I had the same problem when I was your guys' age. Don't worry. I never wanted to ask questions in class because I felt like an imposter. I was like, I don't know how I even got to like this level in physics. Like I must be like just really faking it. And if I show that I don't know it, they're gonna know I'm stupid. So yeah, dude, I get it. That's what office hours is for. Office hours in college is when instead of asking in the class, you go to the professor's office and you ask him one-on-one. And it's supposed to be better because, you know, you don't feel as embarrassed because there's not really many kids at office hours usually. I wouldn't go to it just because I was lazy, but also I didn't want the professor to know I was stupid. Which is also dumb. Like your professor will know you're stupid when you don't get it on the exam. You might as well fix that first by, you know, getting help from them, you know. And there's no such thing as stupid. You just don't know it yet. Anyways, end rant. Yeah, what is delta y over delta x? If we're doing like a graph, right? Right? This is, right, delta y, this is delta x. What does that describe? It's a gradient. Yeah, that's a fancy word. It's just a slope. Slope. X graph, okay? That's all it is. Yeah, it's the slope. Yeah, no fancy words here. Yeah. I should put like something in the stream like this is a no fancy math words zone or something. Well, we can use fancy math words. I like explaining them in like simpler terms, but don't feel like you have to always use fancy math words. It's okay. I know gradient is technically the correct term, but we call it the slope. Like that's the one you know, right? Okay. So the slope of this is the velocity. Does that make sense here? So velocity, right, is delta x over delta t, which is the same thing as delta y over delta x. So that's the slope. And look here, do you see, like, let's look at the slope, right, from 0 to 2 seconds, right? What is that slope, if you had to calculate it? See how this is like 0, 0? And then this is 2, 4, like right here. What would that slope be? The derivative. Ooh, pen center. Yes, that's an okay word. I allow that one. That one's okay.
Nice.
One sec, let me do it. Yeah, good. Do it. Do it. I want you to do it. Oh, man. How long are we doing? Oh, 2 hours and 20 minutes. Monday streams are always really long. I'm okay with. You got it, doggy. I know you do. Is it 2? Yes. Yeah. Good. Because, yeah, what you did, right, is you did y1, or y2 minus y1, that's 4, over x2 minus x1, that's 2. So the slope is 2. And notice that the slope is the same everywhere here, okay? So on my velocity graph, right, remember velocity graph's the slope of this. I'm going to go up here to 2, and I'm going to put a straight line from 0 to 2 in terms of time. So this is 1, this is 2, okay? So this right here, right? This is the velocity. The velocity from from 0 seconds to 2 seconds is a constant 2. All right. All right. Now let's do this. What's the velocity between 2 seconds and 3 seconds? What's the slope there? Yes, between 2 seconds and 3 seconds. Yeah. Between 2 and 3. So what's the slope? Yeah, the slope, yeah, between here. Between here and here, dog. Does that make sense, dog? Like, what's the slope right here? The slope here we figured out right here. The slope here was equal to 2. What's the slope here? It's okay. Okay. So slope, right, is the steepness of the curve. It's okay if you're confused. Don't worry. So see how this has a this has a steepness of 2, right? And if you ever want to find the slope, right, you just take 2 points. Is that how you found the slope? Did you do 4 minus 4? Sorry, 4 minus 0 over 2 minus 0 to find it from this point and this point? Yes, okay. Well then, if I want to find the slope here, dog, right, from this point to this point, do you see how that's just 4 minus 4 over 3 minus 2? Which is just what? Zero over 1. 0 over 1 is just 0. So the slope here from 2 to 3 is 0, which means the velocity is 0. That's why, like, when we were describing the motion of this thing, right? Remember we said, like, oh, it moves here, and then it just chills here for a second. It's not moving at all. That's what this is. That's it not moving. Does that make sense, dog? We got one last part left. One last part. Sure. Okay. So you figured out the slope here, right? We had 2 points, right? I had 2 points. I had 2 comma 4, right? And I had 3 comma 4, right? That was the point here and the point here. When I figured out the slope of that, right? That was y minus y. So that's 4 minus 4 over x minus x. That's 3 minus 2. 0 over 1. 0 divided by anything, as long as it's not 0, is 0. So 0 over 1 is equal to 0. Which means the slope is 0, okay? Remember here that the slope of the position is the velocity. You may have also heard of slope described as the rate of change. Have you heard that before, like the rate of change? It's like how much this is changing when this is changing. So the amount that the position is changing divided by the amount the time is changing, like, so the amount of position per unit time that's changing, that's the velocity. That's how fast something is. So the slope of this is what this is. And so the slope here is 0, which means on my velocity graph, I'm going to put a line from 2 seconds to 3 seconds at 0. And if you want to visualize that, so here, let's just visualize from here to here so far, right? So for the first 2 seconds, right, it's moving kind of quickly, right? It's moving that at, we're going to say 2 meters per second. That's the speed. Then, from 2 seconds to 3 seconds, right, it's just going to stop. It's just chilling here, right? That's from 2 to 3 seconds. Does that make sense? Okay. What happens during leg C? What's happening during C? What's happening to the position? Where's it going? It's going down, right? So it's going to start coming back. Right? So it's going to start coming back. It's going to go from 4, right, all the way back to 2, okay? So we want to draw that on our velocity graph. What's happening with that, right? How can we do that? What is the velocity graph again? What do we know the velocity graph is? How do I get the velocity graph and the position graph? The slope, good. So what's the slope, or the gradient? Yeah, what's the slope here? If you ever get confused, right, you can always just take 2 points. Take 2 points on it, right? Let's take a point here. Let's take a point here, right? This point is 3 comma 4. This point is 4 comma 2. You can calculate the slope between 2 points. This is why, again, math always builds on itself. Is it 0 over 1? Close. A little closer, okay. Remember, it's y minus y over x minus x. What does that get you? close. Negative 2 over 1. 2 minus 4 is negative. All good. Yes, good. So on my velocity graph here, right? Between 3 and 4 seconds, I'm going to put a straight line at negative 1. Wait. Okay? And this should make sense because the velocity is negative because it's going the opposite direction, right? Instead of it, you know, going more this way, it's coming back, right? Because it's coming back, right? That's why it has a negative velocity. Does that make sense? Yes? Cool. Awesome. Great. Good job, dude.
That's dope. Well done. Well done.
Yeah, you're very welcome. Yeah, please. Yeah, anytime you got stuff like that where you're like, I don't get it, or we're going to learn it next, like, yes, I teach a lot of fucking physics. So I know everything in physics. I know what you're going to learn next. So let me help you out. And, like, you know, we can see there's a bunch of, like, small little things that I know you guys did not learn because of COVID and all the online learning, right? Where they're like, oh, turn on your webcam. No one turns on the webcams. I know what y'all did. Y'all didn't learn shit. I know you did. It's okay. We were not ready for the pandemic. But the whole point of this whole stream and stuff is to patch those holes so that you don't get, like, you know, screwed in later classes. So, yeah. Plus you get prizes. Yeah, right? I think you got your Steam gift card yesterday or something, or today. I forget. What are you gonna buy with it? I always ask the students, like, what are they buying with their gift cards? It's kind of fun. I think I need to get Helldivers. Apparently that game is dope.
I was going to say, kids, don't worry. You've only lost a couple of years. I've lost 20.
Waited for Hades to get on sale. Yeah. A couple of years you've waited 20, Sensation. Yeah, dude. As long as you do it. What's this game? It's called Hades? Steam. Hades. Is it something like this? Hades 2? This looks pretty cool. What's this game? Ooh. Oh, Hades 1 isn't out yet. Hades. Hades 1 Steam game. Hades, there we go. Oh, okay. Nice. Cool. Well, yeah. If you get tier 2, that's a $20 gift card, so that'll be $30. So total. So yeah, you can you could then buy it. You can play it. That's great. I love that. You know, always encourage people to play new games and stuff. That's actually what, like, the tier 3 reward is. I'll buy you any game as long as it's like under $60. You know, I bought someone Madden the other day. It's on sale. Okay, cool. Yes. What is Ethan doing? Ethan, are you here, dude? What's up, Ethan? Ethan's probably our last question of the day. Hades is hella. Yeah. Is it dope, Ian? What type of game is it? What type of game is Hades? 1 second. I gotta see. Hades Steam game. I'll just play the trailer. They usually have a good trailer on it. Let's see. This looks like some anime stuff. Like, where's some, like, actual gameplay? Oh, okay. Ah, okay, cool. It's like almost like a Baldur's Gate kind of, but probably not as complicated.
Stupid boy. I told you nobody
What's up, Ethan? Yeah, good to see you, dude. It's an AR. What is ARPG, dude? What is that, Ian Stucky? What do you call an ARPG?
I was like, well, I might not have much time to do this because I have a lot of work to do.
Okay. Do you need help with any of your work right now, or is none of it math and science?
Well, there were some people who did ask questions that I was going to ask, so it's not really that much.
Okay. Oh, because Wolf Slayer? Did Wolf Slayer ask a question? Was that the one that we went over?
Yeah.
Nice. Do you want to do a practice one like Wolf Slayer did, just to make sure you know how to do it?
Yeah.
Okay, let's
just thing though.
Yeah. What's up, dude? Or you mean just one question? Oh, action RPG. Okay, nice. Yeah, I like Diablo. Diablo's great.
Okay, yeah, that's it.
Okay, here, let's do it. All right. Okay, let's make a fun one. Let's say, want to do here? Okay. Let's say the volume of a cube, right, is equal to 4/3, or, you know, I want like some weird like thing. What's some weird one? Let's say volumes of shapes equations. I
you
want
could use any general formula, right? Like
I know, but
maybe
I want
something
something with like some fun stuff
equations.
on it, dude. Like where's some weird ones? I want something that has like a bunch of pluses and minuses in it or something. Yes, there we go. Awesome. Yeah, love this. Here we go. Let's get weird. What's up, Twitch? See, we've got 20 viewers here. Nice. If you found us on Twitch from wherever, one of our cool math streamers and stuff, go check them out. They're awesome. Here are all their Twitch streams. We have a whole schedule that all throughout the week you can learn all sorts of cool math and stuff. I tutor everything math, science, middle school through upper high school, like maybe a couple first year, 2 years of college. If you have any questions, join our Discord. There's a link that gets spammed all the time, or you can see it. It's like right there. So that's the best way to get help with your questions. All right. Yeah. Okay. Look, here's an octagonal prism. This looks pretty cool, right? Doesn't it, Ethan?
Yeah.
Yeah. Right. This kind of looks like a pool or something, right? Or actually, no. Let's do this. Let's do the trapezoid. Let's do the trapezoid. So here, the volume of a trapezoidal prism is equal to 1/2 a plus b times h times l. Okay. And I want you to solve for b. How am I going to solve for b here?
Hold on. Give me a little. I'm texting someone here.
Okay.
What are you doing? What are you doing?
Nothing. Me? Just hanging around.
Right.
Ready?
Say that again.
Okay, so here's the equation for the volume of a trapezoidal prism, and I want to solve for b. How do I solve for b?
So, maybe you could get rid of the fraction,
Yeah, let's get rid of the fraction. How do I get rid of the fraction?
multiply it by 2.
Good. Nice. So we're gonna multiply both sides by 2, right? So here, let's take this down. Yeah, that's funny. I was teaching Wolf, right, how to divide fractions. I don't think he knew how to divide fractions. Which is good. I mean,
Yeah,
that's the
we
whole
were
point of
going
this
over that
stream,
in
is to
class.
like figure out what you don't know and like fix it. What were you gonna say, Ethan? Sorry? Say it again.
Yeah, I guess so.
Yeah.
I guess like look, we were thinking the same thing, so we should learn the same level. I guess he didn't know.
Well, no, but everyone's different, right? Everyone learns at a different rate, and everyone has different experiences. Like, you haven't lived the same life that your friend has, so
Yeah,
maybe
I get it.
he was sick when like your teacher went over dividing fractions. I agree that you should all know the same thing, but
He wasn't sick. He was
Well,
not sick.
I don't know. Okay, you're right. Okay, so this goes away, right? Goodbye. Right? Okay, cool. Now we're left with this. V is equal to a plus b times HL. All right, what do we do next?
Hold on. Wait. I would actually follow a rule of distributing, but the H and the L are on the opposite side.
Yeah, we want to solve for b. I mean, you could. This is okay. You could distribute this in, and that's totally legal if you want to, but it would make things messier. Because remember, we're just trying to get to this, right?
Fine.
So instead of like distributing this and making this like a whole mess, let's just attack stuff on the outside, right? What's the stuff we're trying to get rid of?
Wait. Sorry, say that again.
What are we trying to get rid of here, right? I'm trying to solve for this.
We're trying to solve it. So we're supposed to get rid of A, H, and L.
Good. Which one am I going to get rid of first?
Maybe the A.
Well, getting rid of the A would be difficult, right? Because how would I get rid of the A?
I really do not know. Just minus A on both sides or something.
Right, but minusing A, minus is on the outside. You can't just insert it in here. You can't do that. No. Can't do that. It would have to go on the outside, right? And then you have this thing in the way, which is like is a mess, okay? Let's get these things out of the way first. How do we get these things out of the way?
The divide on both
Good.
sides.
Nice.
Yeah. By what?
HL.
Good. Good. This goes away. Now we're left with V over HL is equal to A plus B. Okay, we're very close, right? What do I do next?
Now you can minus A, since it'll make it a lot more smoother.
Good. You can also get rid of these parentheses. We don't need these parentheses anymore. Because they're not doing anything.
It's just two things.
They're not doing anything. Good. So you can minus A. Okay. So now you get V over HL minus A is equal to B. Okay. Now, technically we are done. We did solve for B here, but your teacher wants you to like make this look nicer. They want it to make it look like it's one fraction. How would I do that?
But wouldn't it be something like V over AHL?
Close. Okay. So what you want to do here, Ethan, right? Let's rewrite this as a fraction. How can I write A as a fraction?
I feel like this has something to do with laws of indices.
No, not indices. It's not laws of indices. That's exponents. We don't have any exponents here.
Okay then, whatever. All right.
It's okay. This is just subtracting fractions, right? How can I write A as a fraction?
Oh wait, 1 over A. Right?
A over 1. A over 1. Yes. Good job. Wait, is that Cypher? Cypher? Yeah, you're Mr. Pink. Yeah, you're the only person that's Mr. Pink, Cypher. What's up, Cypher, dude? What's going on, dude?
Okay.
Come on the stage. Come say hi. Okay, once I have this, right? How do I get these two things to subtract each other? What do they have to have in order to subtract fractions? Hell yeah, brother.
I didn't get that clear. What? I didn't hear you much. What?
I want to subtract two fractions here. How do I subtract those two fractions from each other? What do they have to have that's the same?
Lowest common multiple?
Yes. I mean, that's a nice word, but they have to have the same denominator. That's what they have to have.
They didn't even got that. So don't they gotta be something like, just isn't it just HL since they can just, I don't know. Well,
Yeah.
and
Yeah,
they multiply each other and then just go up to HL.
I would like for this to have an HL, right? The HL already has a 1 on it, basically. It's just an imaginary one,
Yeah.
right? Or not imaginary, but it's like invisible. An imaginary one would be like this. We don't want that. Nope. Okay. Yeah. Okay, so I want this to have HL. How am I going to get it to have HL?
Wait, what? It doesn't make sense. What?
How do I make the denominator HL?
Don't you multiply HL then?
Where?
Both sides?
What are both sides?
Okay, this is really confusing. See, I'm under too much pressure. That's it.
It's okay. No pressure, bro. You're chilling. You want to multiply the top and the bottom by HL. That's what I'm... When you say both sides, I don't know if you mean this side and this side, or if you mean the top side and the bottom side.
No, I meant like two left and right, not both.
No,
top
no,
and
no.
Bottom.
Top and bottom. Yeah. Because this, Ethan, right here, HL over HL, this is the same thing as 1.
Nice.
You see how it's like the same thing over itself, right? That's just multiplying by 1. Okay, because what this does, right, is this is going to turn the denominator, right, now into HL, and now this is AHL. Okay?
Okay.
Okay, now I can combine these two things, right? How can I combine these?
Wait, which two again?
These two fractions?
Wait, is that an E?
No,
Or is
it's an
that
L.
ET?
It's an L. It's an L.
That does not look like an L at all. No
It's an
matter
L.
what you take it as.
L's.
Man.
L's in the chat.
Alright, but, wait. Don't we go back to the same thing where it's like V over HL minus A over...
No. V over HL minus A over HL is V minus HL all over HL.
Okay then.
You see how you combine these? Wow, thanks for the follow, dude.
Yeah. Okay.
Sick. Good job.
That's dope.
What up, my boy Cypher?
What up, bro? How you doing, man?
How's it going, bro, dude? How's your Monday? Happy fucking Monday, dude.
Yeah, dude.
Fuck
I'm
yeah,
in the
dude.
fucking army now.
You're in the army? I saw,
gotta leave
dude.
now.
All right, good to see you, Ethan, dude. Yeah. What part of the army are you in, Cypher? What are you doing?
Like, what is my MOS?
Yeah, I guess you're like an ensign. Is that what they call it? Is that like the basic one, or is it private first class or something? I'm trying to remember all the stuff.
Private first class is E3. That's
E3.
like rank.
Okay, got you.
That's okay. So the pay grade is E1, 2, 3, and then so on.
Yes.
And it goes like warrant officers, which are O's for some reason.
Yes, that's what they
But
call
I'm
it.
an E2.
Officer Training School, right? OST. Officer Ready. I forget what it's called. Yeah, something like that.
OTS.
OTS. There we go. I thought about going to OTS.
But I'm not an officer.
Not yet.
I am.
Not yet.
I hope that I don't become an officer.
Why?
I do not want
What's...
to deal with these fucking trainees.
Oh no. Oh, that's cool, man. I'm glad. You graduated school and stuff, yeah?
Yes.
Hell yeah, dude. I remember earlier you were wanting to just quit school and like go be a roofer, and I was like, no, dude. Make your own career, dude. Make your own life. You got it, dude. And like having a high school degree is like absolutely necessary for that.
Yeah. I'm currently in AIT, which is basically college but for the army.
That's cool.
I'm doing a 6-month college course.
What's the
We have
course
to
called?
finish it in 6 EMT or some shit. NREMT.
ENRT?
And NREMT or some shit.
NRENT.
NREMT.
So wait, are you like a
I'm a
medical
combat
person in the army? Is that what it is?
Yes.
Oh,
I
very
am
cool.
a 68 whiskey combat medic combat medic healthcare specialist.
Medic specialist. That's dope, dude.
Yeah. I've also
Oh.
lost about 50 pounds. Or
Wow.
about 40 to 50 pounds.
Hell yeah, dude. Dude, that's what the military is great for that, dude. The military will teach you discipline. It will teach you to fucking lose some weight. Cause like, bro, you can't be fat in the military. Well, the army can be, right? You definitely have some fat people in the army, but like, you know, if you want to really like get up there, you can't.
Just in my fucking company commander, fucking basic.
Yeah.
Big.
Right, but the Marines aren't, right? The Marines, like, you definitely can't be fat. They just won't even let you in if you're fat.
I don't know about that. I don't really know nothing about the Marines. We don't do nothing with the Marines.
Well,
I mean, I'm currently at Fort Sam Houston, which is a joint military base.
I'm seeing that right here.
Yes,
Yeah. I see the one in Sam Houston. That's very cool. I forget, we're both from Houston? I grew up in Houston, close to Sam Houston.
Sam Houston is in San Antonio.
Oh, it's not Sam Houston State. I'm thinking of like the college, Sam Houston State.
There's a college called Sam Houston.
There is a college called Sam Houston State. Yep, Sam
Yeah,
Houston State College. That's in Huntsville, Texas. That's a little bit north, but that's cool. Okay, dope. And you like it? You like the combat medical stuff? That's cool.
I mean, I like the knowledge part of it. I don't like the army part of it.
Oh, you don't like that you have to wake up and like make your bed and then like wake up at 6 a.m. and go run 10 miles and all that shit?
No, we don't wake up at 6 a.m. We wake up at fucking 5 a.m. Tomorrow we got a formation at 5:45.
5? I couldn't do that. I couldn't do that, man. What? No.
It's like almost every fucking morning.
Yeah.
And we're not allowed to have like a bunch of stuff like sugar, like sweets and shit. It's
Yeah.
considered contraband.
Oh, candy's considered
so
contraband.
Yeah. So if we get caught with it, we get like what is it called?
Demerits? Or like
Yeah.
100 push-ups?
No, it's like it's a piece of paper or counseling. You get counseling.
You get counseling. That's
is-
nice.
Yeah. And so far I haven't gone to counseling yet, but I have
I'm very proud of you.
Skittles, hot Cheetos, Strawberry
He's got all the contraband.
Skittles, Jolly Ranchers, and
Oh,
Werther's Original.
my man's stacking up. Well, I mean, whatever, you know, you're in the army, whatever comforts you can have, you know, do it. But you'll find that like that type of food kind of like holds you back, right? Especially if you got to like start, you know, doing more intense like physical stuff.
No. Don't get high on your own supply. I've made over $100 in basic just selling this
Oh, you're a contraband street dealer for the candy in the army. Okay.
shit. Yeah, dude. Fucking. I'm making bands off this shit.
I'm glad, dude. As long as you're still hustling, what? You're losing 50 pounds. I'm happy for that. You're learning stuff as a combat medic. You're, you know, you're educating yourself. We're luckily not at any serious wars. So, do you have like a deployment schedule? Are they going to put you somewhere after this?
Considering everything that's currently going on in the world, then like, yeah, I'm most likely gonna get deployed somewhere.
Like Middle East, probably. I'm guessing, right? We just keep fighting. Over
Like Europe, probably like Russia and Ukraine is fighting.
Okay.
And then I heard something about Turkey, but I don't know nothing about that.
Yeah, the whole world is a mess right now. So, and I know the army's been having a lot of problems with recruitment, like getting people in. So they must appreciate you, you know.
Fuck no, they don't.
Fuck no, they don't. Well, they should. Anyways, okay, I gotta run, Cypher, dude. But that's super cool to hear from you, man, dude. Like, I love to see like where the students are going. I would love to like hear more about your story and stuff as it goes on. Please like come by the Discord and just like tell me what's going on. Like,
I'll come by as often as I can.
Awesome.
I literally got out of formation like 20 minutes ago.
Oh hell yeah, dude. I love that, dude. He gets right out of formation and he comes to the actual education Twitch stream, dude. Fuck yeah, dude. Shot. Cool, Syph.
Sounds good. You too.
Peace. All right, thank you everyone for coming to the Golden Hour, not Golden Hour, sorry, to Office Hours. Had a lot of fun learning with you guys. Big props to all our subscribers, Discord boosters, any students here that came by, asked questions. I love all you guys. Keep me relevant and stuff. I'm here to help. You found us on Twitch. Yes, come join the Discord. Yeah, I love you too, Cypher, dude. Yeah. Let's see. Next stream is going to be on Tuesday. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. If you got more homework questions, come by then. If you want to just come by and chat, we'll be there as well. And then, yeah, if you're in our tournament for the PS5 and stuff, I'm going to be making announcements tonight about more of the challenges and what we're doing next. Okay. All right. Next up, let's see. We're going to go raid someone because we got 15 people here. Like, who should we go see? Wow, lots of people. Danny's doing... It's a raid. It's like you go and like just like check out someone else's stream or something. Let me see. Where are the I haven't raided the science people in a while. Let me go see what they're doing. Sometimes they do cool stuff. No, they're great, dude. I love the science guys, dude. Yeah, they're talking about volcanoes. Yeah, okay, cool. Yeah, let's go say hi to science. Yeah. Go say hi to science. They're cool people. Jinxie, no, we can't go watch Rainbow Six Siege. All right. Anyways, yeah. I need to get that game. It's 9 years old or something. But yeah, go say hi to the science people. Man. Go learn about volcanoes. And then I will see you guys tomorrow. I gotta go teach soon. Cypher, stay good, dude. It's great to hear from you, man. All right.
Man.
All right, peace, dude.
Hi, Yogurt Daryl.
See your butt.
Well, that's for the Antonia butt wiggle, you know.
That offspring can breed as well. And what?
Ah! Coffee.
Cracks it then, and it.
There's no underpants worn by these animals. Every other name we go, you know, like Thuggy, Jern, Barty, Jern, Claire, Jern, Date Night In, Jern, Big Gaming, Jern, Jern. Actual education, welcome in, Raiders!
Science stream, but we ain't bugging. We over here buffalo. You be chugging what we got. Now the tribes arrived. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Raiders, welcome the heck in. Actual Education. Apologies, I had just stepped away running to the restroom. Welcome on in. Raiders, how was your stream, Actual Education? Tell us all the details. My name is Belent. I'm 1/3 of Science Streams. The other 2/3 are my lovely wife, Lita, and our daughter, baby Alona. We're research scientists, and we do interactive live science streams here on Twitch 7 days a week. With microscopy, art, sci-fi, science, science news of the week, deep dive scientific topics, games, 3D printing, IRL streams, model building, and more. Today we have on Volcano Doc, Professor of Volcanology, and we're discussing fossil science. And yes, NME Soldier, Thug Shells made our theme song as well. At the beginning of every stream, we play a theme song, and here